Hi everybody, can you hear me? Can you see my screen and hear me? Can you give me a thumbs up if you can hear me and see my screen? Can you hear me? Can you see my screen and hear me? Yeah, I think my voice is coming. I was checking in a different phone. Okay, so welcome to today's session, guys. And again, very interesting session we are going to have today. What we are going to do is we are going to extend our previous learning that we have learned in part one. And what was the part one? Again, if you have not watched, I encourage you to go to Unfold Data Science YouTube and watch the part one here, Unfold Data Science YouTube, and you can go to the live and you can watch the part one. So what we are trying to do here is we are trying to do a three-part AI engineering workshop. Okay. And in this workshop, it's not gonna be only talking or only study level things. It's gonna be um, production level things that we are talking. Okay. So this was the part one done a week back, and today we are doing the part two. So before we do part two, let's quickly revise what we did in part one. Okay. So that all of you can understand what we are talking here. And if you like the part one or if you are liking this one, please give me a thumbs up, guys, and we are getting started. Just say thumbs up and we should get started. Okay. So first of all, what we did is in the last part one, just a quick revision of what we built. Okay. So we built a fully functional RAG. Okay. RAG is standing for Retrieval Augmented Generation. Fully functional RAG is what we built in the last session. And what is the meaning of a fully functional RAG in general is basically a RAG will do few things. Okay. A RAG will take a user query. I'm talking about the inference time. I'm not talking about the training time. RAG will take a user query. Then what will happen as the next step? Then retrieving will happen. Let me put it here. It's little difficult to write. Then what will happen is retrieving will happen. First user query will come, then retrieving will come, and then what will happen is top k results, or in the language of RAG we call it top k chunks. Okay, so I will write here top k chunks will come. How many ever chunks you want, those many chunks will come, and then from these chunks context will get prepared and it will get sent to LLM, and from LLM user will get the response. So this is the flow of a typical RAG. Okay, traditional RAG basically. This is what you call as a RAG. Now, in last session, I had explained you in detail what is the difference between pre-training or preparation or data preparation or knowledge preparation, and what is the difference between inference. Okay, so here I'm talking about inference part. What I'm talking about? I'm talking about inference part here. What we are going to do today is we are going to build some production ready things in this RAG, or we are going to build basically a production quality RAG. And what happens in production quality RAG is it is not only this much, because we cannot depend on RAG giving us the right answer and everything working so nice in the first go only. So we are dependent on many other things. So what are these other things? We will just write it here. So this was your session one. To the people who have joined now, we are doing a three-part AI engineering workshop, and this is your session one. And today is my session two. So in session two, as I told you, we are going to understand some very critical components of RAG. So the first part will again start from query. Okay, but after the query, when the retrieving happens, it will happen little differently. Okay, so it will not be a plain retrieving. So retrieving will happen first using something known as by encoder. Okay, and what this by encoder will do is I'll tell you in a moment what it will do. And then one new step will come here, and this is called re-ranking. In RAG, re-ranking is a very famous interview question. You can expect this in any generative AI interview, okay? So re-ranking is what I'm going to show you now, how re-ranking works. And after that, what is going to happen is we are going to see top K. So top K based on the re-ranking. And then we are going to see very, very important part here, evaluation. Evaluation of RAG, how to evaluate RAG. Okay. And then we are going to understand how to send this to LLM and how to get the response. And in between, we will learn one more thing, additional thing, which cannot be fit into the sequence, but that is a technical thing basically. That is known as, that terminology is known as chunking strategy. So that also we will see. But the new things we are going to see is retrieving using bioencoder, re-ranking using something known as cross encoding. Okay, this is called cross encoding. Very, very critical component. We are going to see evaluation of RAG, how to evaluate your RAG and how to tell that your RAG is good or not good, or how do you say to somebody that your RAG is doing what it should do. So we will see bioencoder, cross encoder, retrieving, re-ranking. We will see evaluation, and we will also see chunking strategy. Okay. So first of all, let me launch the UI, and then what we will do is we will see the UI, and from the UI we will understand the theory, and from the theory I will take you to the code. Okay, so this is going to be the flow. So first of all, I will show you things in UI. From the UI, I will take you to the uh, theory basically, or understanding of what is that, and then I'm going to show you the code. Okay, so this way it will be very clear to you what is happening. Okay, what is happening. Now, let me go to my cursor and try to launch the UI first. So this is my cursor, and I will launch a Streamlit app here. And when I launch the Streamlit app, right, you will see that few things are happening here. And I'm going to take a relevant query from the Weaviate Cloud. For example, this is a relevant query, how high radial velocity precision, because this is the data I have loaded. Now, these things I have covered in my part one, guys. So everything I will not go in much detail. But these I have covered in part one. How did I load the data? How did I build the basic RAG? Okay. So I'm just trying to take a basically meaningful query. Okay. So I'm taking this meaningful query and I'm putting this here. Okay. I'm putting this here and I'm saying search. Obviously, I have taken help of cursor to create the UI and many other pieces that I thought are useful. But I'm going to explain you everything, and it's very smart to learn using AI, guys, nowadays. Okay. First of all, when I search this on the left hand side, as you can see, this app will demonstrate you 5 metric to measure retrieval quality, improved retrieval with cross encoders, and different ways to split documents. Okay, so this is our part 2, advanced RAG features. So what we are going to learn today, we are going to learn advanced RAG features. Okay, so what is happening here is, first of all, this is just a heading, don't worry about it. I'm asking radial velocity precision and I'm saying search. This is the answer I'm getting from my RAG. And first thing you will see is RAG evaluation metric. And in this evaluation metric, this is again an interview question, guys. When you go to interview, they'll ask you, how do you evaluate your RAG? Okay, I'm going to explain you all these things, don't worry. But I'm evaluating my RAG on 5 things: precision at K, recall at K, MRR, NDCG at K, and F1 at K. Currently, my score in all these is 100% for this particular answer or this particular fetch, basically. Okay. And here I have given some knowledge here to understand what are these metrics, but I'll explain you. It will be very easy. This is about your evaluation metric. Second part is re-ranking. Re-ranking is basically a concept where whatever default chunks you get, you re-rank that based on something else. Okay. So this is your before versus after re-ranking. So this is your re-ranked score for this particular query. Okay, so previous score and re-ranked score. Is this moved? Yes, this is moved. How re-ranking works, we are going to understand. Don't worry. This is your chunking info. So here we are taking a fixed size chunking, but this is a configurable parameter which we can configure in our application. Okay, and here I have again told you what these different parameters will do. Okay, and here are the retrieved chunks. So 5 chunks we are retrieving. Chunk 1, 2, 3, 4, and 5. Fine. What we are going to do now is we are going to one by one and first of all understand what is the meaning of evaluating a RAG and how do you do the RAG evaluation. So let me go to my note and I'll explain you what is RAG evaluation first. Okay, so I showed you UI. We will keep going back to the UI, but first let's see what is the meaning of RAG evaluation. Okay, and by evaluation, if you have little understanding of machine learning or data science, you know what is evaluation basically. You have one data against which you will compare. Okay, so suppose your RAG gives the answer to it. There is a user query and query is, for example, capital of India. Query is capital of India. And the answer that your RAG gives, is basically New Delhi. Okay, New Delhi. Now this answer should be evaluated against something, right? Then only we can say that um, how much accurate our RAG is. This answer needs to be evaluated, right? So for that, we need something to evaluate against, right? Something to evaluate against. So what is that something? What we are going to do is we are going to take this user query itself and we are going to compare how much user query is there in the answer. So for this example, capital of India, New Delhi, it's not making much sense. But for example, if you take another query, for example, neural network, okay? Neural network. And your answer says something like neural network is something, something, right? So here we can compare user query with the answer. So this can be done in two ways. One is either you compare query with the answer or you have some ground truth. You have some human prepared answer against which you can compare. Understand the difference, guys, okay? You have a query, okay? You have an answer, RAG answer. This RAG answer you can compare against either a human prepared answer, okay? Or for simplicity, you can also compare it against your user query, like how much is the coverage. So for example, neural network is my query. My answer says neural network something something. So what I can do is I can I can evaluate my RAG based on this as well. So this is about what do you compare and what against what you compare, right? Which of these two methods you think is better? Just comment me in the chat so that I will understand what is your understanding of this. Meanwhile, evaluation metric we need to understand. The first evaluation metric is precision, precision at K. Okay. This is the first evaluation metric in RAG. What is the meaning? Relevant, relevant items, relevant items in relevant items in top K. Okay. And meaning is, as I'm saying you in the interviews and all, they ask you these things. Okay. Of top K chunks, of top K chunks, how many are relevant? How many are relevant? So let's say the top K chunks, let's say in your top K chunks, 3 are relevant. Let's go to UI. Let's go to UI. How many chunks we are fetching here? So if you go to retrieved chunks, right? We are fetching 5 chunks. Okay. Out of these five chunks, how many of these chunks are relevant to this query that we have asked. Suppose 3, then the precision becomes 3 by 5, which is 60%. That is about your precision. So this is very similar to if you are understanding how machine learning precision works, right? Similarly, recall. So it is chunk by chunk, okay? It is not word by word. It is chunks relevance that we are trying to understand, not the words relevance. And chunks relevance also you can define. I'll show you in code how it is working, but you can define in multiple ways. For example, if you want to see how precision is done in the code, right? So go to evaluation, go to precision at K. And what we are doing here, list of retrieved item IDs, set of relevant item IDs, number of top items to consider. So if you see here, we are starting from K, we are taking top K, and relevant retrieve is if that part is in K. So basically, if 5 things you are retrieving, right, and 3 are relevant, then it will become 3 by 5. The same thing that I explained you now. Okay, this is about your first way of evaluating RAG, that is precision. But we will understand 5 different ways of evaluation. First is precision, second is recall. Recall again, relevant items, find, found in top K, and this is other way around, okay? So this tells you, suppose there are 5 things in your, there are 5 chunks. Out of those 5 chunks, how many are relevant for you? This tells you different story. Suppose there are 7 relevant items, then how many of these 7 is in 5? You understand, right? If you have some understanding of machine learning, you will know what is precision and recall, right? Meaning is how many relevant are you able to find? How many relevant are you able to find? Suppose there are 10 relevant items in the entire knowledge base, okay? But in your chunks, out of that 10, only 3 is present. So I'm taking 5 chunks here, right? In these 5, only 3 are present. So that will be 30%, 3 by 10. Okay. This is precision and recall. And again, if you want to see the code, you can see it here. Recall code. So top K we will take, and then relevant is basically length of relevant. So how many total relevants are there? And then based on that, relevant retrieved we will take. Okay. So we will here taking by relevant retrieved. So how many you are retrieving? Then comes your F1 score. Okay. Then comes your F1 score. So what is F1 score? F1 score, maybe you are having some idea already. Precision into recall. It is basically a balance of precision and recall. Okay. Balance of precision and recall. This is about your third evaluation metric. There is a fourth evaluation metric, very important one, and that is known as MRR. And what is the meaning of MRR is mean reciprocal index. And what it does is 1 by rank of first relevance. Understand the meaning of this, guys. Suppose in these 5 you are fetching 5 chunks, right? And most relevant chunk you fetch in position 1 only, which means if the most relevant chunk is found in position 1, that means your MRR is going to be 100%. 1 by 1 is equal to 100%. Suppose your most relevant chunk is going to be, first relevant chunk is going to be at rank 3. Okay. This is your most relevant chunk, but it is at rank 3. So what is going to happen? 1 by 3. That is your 33%. Okay. That is your 33% MRR. So mean reciprocal index. The meaning in plain language is how nicely you are able to fetch. Okay, how nicely you are able to fetch on top positions. If you are able to fetch the most relevant on top position, then 100%. If second position gives you, then it will be 1 by 2, like that. It will keep decreasing. Okay, this is the fourth thing. And if you want to see in the code, MRR, mean reciprocal index, average reciprocal index of the first relevant item. Okay, so for rank item in enumerate retrieved start at 1, so we are dividing by 1, right? For if item in relevant, one basically it is taking an average of all the mean, right? So average of all the chunks basically it is taking, but for one chunk that will be 1 by that number. Okay, and this number will be 0 to 1. If you are getting 1, that's very good. And then last but not the least, NDCG at K. And this is a normalized discounted NDCG at K, right? This is a kind of little advanced method. It is called normalized discounted cumulative gain at T. Means if list of retrieved items order by relevance you will take, set of relevant item IDs you will take, and number of top items to consider you will take. So what is happening? Don't worry about this formula. I'm going to tell you very simply what it is. And this is one of the criteria you will see everywhere RAG evaluation comes into picture. Okay. So this is called NDCG, and this stands for normalized discounted cumulative gain. The meaning of this is discounted gain normalized by ideal gain. So discounted gain normalized by ideal gain. So what it is telling you is basically when you are building, then when you are doing your re-ranking, right? So you remember I told about re-ranking. So these are my initial 5 chunks, okay? But after this, re-ranking will also happen. And when re-ranking happens, then what may happen is, I'll tell you just a moment what is re-ranking, okay? So then it will be easy to understand. What is re-ranking in RAG? Re-ranking in RAG. Suppose you run a user query. So this is a user query. And these are the 5 chunks. 1, 2, 3, 4, and 5. These are the 5 chunks. Now suppose user query is about diffusion models. Diffusion models. Okay. In chunk 1, there is a discussion of diffusion model. In chunk 2, there is a discussion of diffusion model. But in chunk 3, there is a discussion of neural networks. In chunk 4, there is a discussion of diffusion model. In chunk 5, there is a discussion of, let's say, autoencoders. Just an example. This is your original chunks that is being fetched. Okay. When the re-ranking happens, what will happen is relevant chunks will start moving up and swapping the position with non-relevant chunks. For example, first may still be diffusion models. Second may still be diffusion models, but this diffusion model will swap position with this. Okay. And since this is autoencoder, so this will also kind of is a candidate for swapping position. So this is at 5, don't worry about this. But suppose these two are swapping position. So then third will be diffusion models and fourth will be neural networks. So if you see here, the position of 3 and 4 are swapped. Okay. Position of 3 and 4 are swapped. This is nothing but re-ranking in RAG. Now your top 3 is about diffusion models, which should happen actually. Fourth is relevant, but not directly relevant. So it has come here. Fifth is relevant, but not directly relevant. So it has come here. This process is called re-ranking process of chunks. So this is your first chunk, second chunk, third chunk, fourth chunk, fifth chunk. These are also your chunks, but positions are changed. This process is called re-ranking. How to do that, we will see now. But we were talking about this NDGC, right? So discounted gain normalized by ideal gain. And In another words, we can say here, for you to understand it better, quality of ranking with position discounting. Okay. So when the ranking is happening, forget about the position for a moment, but whatever the final ranking are you getting, how good is that ranking? Okay. And this is higher the better. Higher the better. So the evaluation metric that I have put in my new script called evaluation.py, if you see here. So first is here precision. Second is here recall. Third is here MRR. Okay. Fourth is here. And fifth is here F1 score. So as I was telling you, DCG logic is here. Okay. You can see this. All these scores I'm going to compute in evaluate rank function. And in evaluate rank function, what we are going to do is we are going to compare against what? If you remember in the beginning, I told you there are two ways in which you can compare. This is your query, capital of India. This is your answer, New Delhi. This is your query, neural network. This is your answer, neural network is something. You can do two things. Take this query and compare against chunk. That is what we are doing here. The second way would be prepare a set of question answer pair. Okay. Are you with me? The second way would be prepare ground truth. What is ground truth? Ground truth is, for example, capital of India, and the answer here should be capital of India is New Delhi. This is ground truth. Okay. Capital of India is New Delhi. This is your ground truth. In production grade applications, especially in banking, finance, legal, these kind of domains, right? There will be a human who will be writing these ground truths. Okay. And you will have a very, very high quality ground truth. And when you evaluate your RAG, you will evaluate against these ground truths. I'm telling you this so that in the interview, you should not say that I have prepared my own ground truth. I mean, you can do it for demo purpose, learning purpose, but in real world, when you are evaluating your DAG, you need a RAG, you need a proper ground truth. Okay. Here in our example, what we are doing is, since this is also in some way or other uh, uh, a benchmark against which we can compare things. So why not compare against this only? That is what we are doing here. What we are doing, if you see query lower, which means take the user query, convert into lowercase, take all the words, and from these words, right, see the relevance. How do you see the relevance? You see the relevance based on what is the matching score. Okay. So if you see here, consider relevant if score is in top 50%, roll distance is equal to better, or has significant key overlap. If one of these two conditions satisfy, then I will say that particular chunk is relevant. I'm repeating it again. Suppose this is your query. Okay. This is your query. And for an example, I'm saying this is your one of the chunk. Let's say this is your first chunk. What we are doing in our situation is we are comparing query with chunk. Okay. And or chunks. Okay. Chunk or chunks, because we are capturing 5 different evaluation metric, right? Compare query with chunks and then see where does the precision fall, where does the recall fall, where does the F1 fall, where does the MRR fall, and where does the NDCG fall. So for that, we need to call some chunks as relevant and some chunks as non-relevant, right? So how do you call that relevant and non-relevant? You call that relevant and non-relevant based on the matching. Okay. So here we are doing default to worst case if missing. We are taking the chunk text lower, and then we are taking the keyword overlap. You see here keyword overlap. Keyword overlap is we are seeing how many of these words are present in the answer. That is your keyword overlap. Okay. That is one criteria. If this is greater than 30%, then we say that it's a relevant chunk. Another criteria is score. So what is the score? Chunk dot get score. Okay. So this score is basically you can simply think as embedding score, matching score. Okay. Based on that matching score also we will say, and then we will get these 5 metric. So these are our 5 metric in the end. If you see in the front end, right, we are getting 5 metric: precision, recall, MRR, NDCG, and F1. Here everything is 100%. Okay. And whatever I told you is written here. Just you can read it. I'm highlighting. Okay. This is now a very good place for you to revise RAG evaluation. I explained you, I showed you the code, and here one line explanation of everything. So that's the reason I have put it here. These numbers will change. I will change it now and show you how it changes. Let's move to this is about evaluation. Okay. Now let's move to the re-ranking, and I will explain you how re-ranking is working in our scenario. So re-ranking is working in 2 steps. So there is a step 1 and there is a step 2. Okay. Step 1, what is happening is, suppose somebody asks, what is AI? What will happen in step 1 is, system will simply go to the entire knowledge base and find how many ever chunks you want. Suppose here we can configure the chunks. Okay. On the left hand side, we can configure how many chunks we want. But suppose we want 5 chunks. Let's say an example 5 chunks. So in step 1, what will happen is, there will be a chunk 1, there will be a chunk 2, there will be a chunk 3, chunk 4, and chunk 5. Okay. So this will be matched, and using a technique called, what I explained you in the beginning, right? Here in the flow, I explained you by encoder. Okay. This retrieving will happen. So this you can simply think of matching. So your query will go and match and find the best matching sentences or best matching chunks. Okay. This is your first step. Now you have 5 best matching chunks. 5 best matching chunks. This is your step 1. Okay. And what will happen in step 2 is, among these 5, the sorting will happen. So if you remember, I gave you one example of sorting, right? So in step 2, it can be C1, C3, C5, C4, and C2. It is quite possible that after step 2, we will get this rank. Okay. And this will be re-ranking. Re-ranking. The technique used here is called cross encoder. And without going into much detail of what cross encoder is, just try to understand, if you run cross encoder on everything, on your entire knowledge base, right, your RAG will become very, very slow. They will ask you in interview, okay, why can't we run cross encoder on entire knowledge base? So here only on re-ranking you are using a cross encoder. Re-ranking uses a cross encoder model to reorder results by considering the query and document together. So it will take your query and it will take your document together. Document means now the chunks, limited chunks. This typically improves precision of top results. Top results means the 5 things that you have taken already. Why it helps? Initial retrieval usage by encoder, fast independent embeddings. Okay, so I told you here, right? Initial retriever. So you can write here, step 1 is nothing but initial retriever. Initial retriever. What it is using? It is using your fast and independent embeddings. Re-ranking uses cross encoder, slower but sees query plus document together. So this will take all documents and your query and do certain other kind of comparison. Cross encoders capture complex semantic relationship better. So this part you don't do on entire rack. Basically, it's difficult to do. Okay. It's difficult to do this on entire rack. Not difficult, it's slower basically. It will take more time. So what you do is you first do a normal retriever and then using cross encoder, you just re-rank it. Okay. And once you re-rank, you will see that the position of your chunks are changed. Rank 1, 2, 3, 4, 5. Re-rank score 3.8, minus 3.3, minus 4.0, minus 4.4. It will keep on increasing now, negative side. Okay. So again, what we are doing here in re-ranking? We are doing two things. One is initial fetching we are doing, and then we are re-ranking it. What will happen if I remove enable re-ranking? Let's see. So from the left hand side, I'm unchecking this. Okay. Enable re-ranking. And I will run the same query again. Okay. I'm removing re-ranking and I'm running the same query again. Now I expect evaluation metric to change a bit. Okay, it's not changing. Let me increase the chunks. Let me increase the chunks to 7. Search. I want to show you how the evaluation metrics are changing when you don't do re-ranking. So let me take some other keyword from the liquid gas phase transition is hot neuron, in hot neuron. What is neutron basically? Let me ask what is hot neutron? Hot neutron. Okay, so I'm not running re-ranking now. I'm running the rag without re-ranking. See, precision has changed. Okay, and NDCG has also changed, and since precision has changed, so recall has also changed. So what it is saying basically is whatever 5 things or 7 things you are fetching in your retrieved chunks, everything is not relevant to your query. So my query is hot neutron, right? So my precision is low. Precision is low. The meaning is high precision means fewer irrelevant results. Little low means some results are irrelevant. Okay. So we can check that also in the chunk. Basically, if you go to chunk and if you search for that keyword, maybe in some chunk it will not be there. That's what my thought is. Yeah, I think in some chunks that word is not there. Maybe you can check it, but I think it's not there. So that is where your precision has come down. So why we discuss this is basically I wanted to show you if you don't do re-ranking, your RAG's performance is going to come down. Okay, so better to do re-ranking. Now if you enable re-ranking and do the search again, maybe with 7 chunks it might be little precision might be little weak, but let's see. Yeah, precision has improved. If you see, previously it was some 70s, right? Now it has come to 85. So re-ranking is helping. NDCZ is also changed. Okay, so which means that when we do re-ranking, our RAG is improving. That is the key point here. Okay, so re-ranking we understood. So just you can think like first layer is happening on plain embedding and second layer is happening on contextual embedding or semantic meaning. Okay, That is what you can think for understanding purpose now. And where is the code? Reranker. Okay. In this reranker, as I explained you, there is a reranker class. And in this reranker class, what will happen is, first of all, it will take the original rank, and then it will use, if you see here, sentence transformer cross encoder. What is sentence transformer? Who can tell me in comment? What is the use of sentence transformer? Who can tell me in comment? Or cross encoder? No one? No one has ever used sentence transformer? Okay. So basically the same thing that I was telling you, right? First we are sorting on embedding, then we are sorting on contextual embedding. Basically semantic meaning we are capturing. And this is your original embedding, this is your re-ranked embedding, and this is your positional change that we are showing on the front end. Okay, so if you see, we are showing the re-ranked positional change original score. That is your re-ranking. Now the third thing of today's session is chunking info. What is chunking info? Chunking info is very simple. Chunking info is, suppose I have a big document in front of me. How do I want to create the chunks? Okay, so suppose you have the any Wikipedia page. Let's search a Wikipedia page. Wikipedia of generative AI. Okay, generative artificial intelligence. Suppose I want to store this in DB as a vector database. When you are creating chunks, then what you want to do? Do you want to create chunks like 300 words together, one chunk, and next 300 words together, another chunk? Is that what you want to do? Or you want to have an overlap between 300 words here and then start from word number 250 and go till 300. Then again have a 50 word overlap and then create new chunk. Is that what you want to do? Or you want to do a semantic meaning chunk? That also you can do, right? So these are different chunking strategy, and based on this your model performance will change, RAG performance. Okay. And this is normally in any machine, any generative AI project, your chunking strategy should be a part of your configuration. And I think I have also built like that. Go to config and see here chunking config. We are building a production grade application here. Okay. So in chunking config, you can give your chunk length, you can give your overlap length, and you can give fixed size or sentence based or semantic, whatever chunking strategy you want to take. What is the similarity and what is the difference? I told you now in the Wikipedia example. So if you ask me which works good in all scenarios, this question is cannot be answered because it depends. You need to try and see. Okay. But there are different chunking strategy that you should aware of. What are these? We are using now fixed size, and these are different chunking strategies. Fixed size, split text into fixed token windows, and some pros and cons. Sentence based chunking, split set sentence boundaries. Semantic chunking, group semantically similar content. Impact on RAG, better chunking, better context, more accurate retrieval. Semantic chunking often performs best for complex queries. How will you change here in the project? You will simply come here, and in place of its size, you will say, sorry, you will say semantic. That's it. Okay. You will come here and you will say semantic, and your chunking strategy will change. And what may happen after changing this is you need to restore the data once in the vector DB basically. So you remember we ran build index in the first session. So you need to build index one more time, and then you need to launch your app. Okay. That is about your chunking strategy. and then retrieved chunks are here. So basically now I'm retrieving 7 chunks. So all the chunks you can see here. So if you compare with our previous version, as I told you in the beginning, we have done, we are building an advanced RAG here, okay? And when we talk of advanced RAG, then you need to be doing a smart retrieving, which we are doing by re-ranking and by encoder cross encoding. You need to have evaluation metric, which I explained you in detail, and you need to have a chunking strategy, better chunking strategy. Now there are many things with the RAG, but these are most important things. Okay, who can tell me what are other important concepts in RAG? Can you comment me? What are other important concepts in RAG? What are the important concepts of RAG? So there are more things like query expansion, query rewriting, okay? But those are the things we can add, of course. But what we are going to do in the next session is we are going to take this application and deploy it. So in the first session, we built a fully functional RAG, right from query to retrieving. We prepared our knowledge base also in Weaviate Cloud. So some of you, if you are not familiar with Weaviate Cloud, you can go and see my video on this one, build RAG from scratch. You will know how to build a Weaviate Cloud RAG, enabled RAG. Okay. And that Weaviate, we have, this is a vector DB basically. So these are our data here on the vector DB. We have put our data. We have put our data and we have built a fully functional RAG in the part one of our demo. Okay. Today we improved that RAG and we saw how we can incorporate re-ranking, evaluation, and chunking strategies in our RAG. So this RAG is fully functional and better quality RAG now. Okay. Now what we will do as a next step is we will take this RAG and deploy it to the production. That I'm going to cover in the next part. Any questions, guys? Feel free to shoot. I'll take a pause here. Any question? And one more thing I want to let you know that I am launching a AI engineering bootcamp with Super Data Science. This is starting in the month of January. And as you know, Super Data Science is a global name in uh, data science and AI trainings. So you can check this out. I'll drop you the link. This is Super Data Science community where there are 6,000, 7,000 people, and Super Data Science is a very well-known name in the world of AI and machine learning, mentoring, boot camping, training, etc. You can check out this. The global bootcamp price is $6,000, but India price is 49,000 only, and this is launch price. If you want to know more about this, you can just pay 5,000 deposit and talk one-to-one with me. Okay. So I just thought of letting you know. You can simply go to this, read about it, and let me know. Okay. Hello from South Korea. Hi. Hope you are doing good. Missed last session. Same ID used today. Yeah, I'm using cursor, I'm using anti-gravity, and I'm using Visual Code also nowadays. So I'm using many things. Best link to learn SAS and R. I will say you can learn any of these things in ChatGPT or any tool. So let me know, guys. Did you like this session? How did you like it? Let me know in comments so that we can do the third session with more energy. I think we have covered a lot of good things in today's session. And we have seen a fully functional, very good quality rack. So what I will do is I will first of all delete this HF cache from my system and I will push the entire code in GitLab and I will give you the uh, link in the comment of this video. When this video gets released, right, in the comment of this, I will give you the link. Okay. Okay, guys. So if you have any queries on the video, you can write. And I will see you in the next weekend on 14th. Fine. With the third part, the deployment part of the same rack. I will see you with that. Anti-gravity, I have done a full session on YouTube, but if you want, I can do a dedicated session on anti-gravity as well. I mean, one session is already there. If you see here, right, in videos, anti-gravity is there. 30-minute video. It's a very complete video. You can watch that, okay? And then you should also subscribe to my shorts channel, guys. You are not subscribing. So you can go to AI Bits by Aman and subscribe to this if you have not done yet. Here I keep not AI notes, AI Bits. Here I keep sharing short content. Okay. So if you want to learn short contents, basically in the short way, you can subscribe to this channel today. AI Bits by Aman. Okay. Just do that. If you see, I'm sharing a lot of interesting things here. 90% of AI startups will die by 2026. The AI revolution is here, dark side of AI agents. So I'm sharing a lot of nice things here for you. Just go ahead and subscribe to this AI Bits by Aman. Okay. Okay. Thanks everybody. I'll see you in the next session on next Sunday. Okay. Take care. Bye.